Now, elements of mechanical engineering. Now, if you just start with it, it has, if you look into mechanical engineering, you have two things. One is uh, mechanics, and the second one is strength of materials. Okay, so if you look into mechanics, what does mechanics do is actually you apply a load and its components are calculated. Now, if the components are calculated, you have applied a load, the components have been calculated. Now, these components lead to the distribution of forces. We calculate that what is the distribution of forces across, let us say, any plane, surface, or a body, anything. So we actually calculate the distribution of forces. In strength of materials, we apply a load. Now the load has a certain effect, and this effect needs to be studied. So for example, let us say that a body is being acted upon by 100 kilonewton force having a cross sectional area of 10 meters square. So you can say that the net stresses produced is 10 newton per meter square. So this is mathematics. This is simple mechanics. You have applied a force, you know the area, or you know that a force of this magnitude has been acting at this angle. So the two components, per vertical and horizontal, you can calculate the components, and your job is done. Now, by knowing this is the mechanics part is actually mathematics. Even strength of material is mathematics. The mechanics part is actually mathematics, and this mathematics is not concerned with what happens to the body due to this type of loading. In strength of materials, what we do is you have a load, the load will produce an effect, and you need to understand that if the ultimate strength of the body is 8 newton per meter square and the stresses generated are 10 newton per meter square, the body will fail. So you cannot load it. So what you are doing is you are arriving at inferences. So what will be the necessary inference? You study it. So one option is change the material. If the stresses are beyond a certain limit, what you can do is change the material. So to change the material, again you should know the property of a material. So how will you change it? You will change it by a stronger one. You need a stronger counterpart to change it. भैया अगर आपका एक कंपोनेंट कम लोड की वजह से मैंने एक लोड पे फेल कर रहा है तो इसका मतलब एक ऑप्शन ये होता है कि लोड कम कर दो. लोड आप कम नहीं कर सकते. इंजीनियरिंग में आपको कभी भी ये चांस नहीं मिलेगा कि आप लोड कम कर दो. If somebody says that कि आपको एक मोटर डिज़ाइन करना है, let me give you an electrical example, आपको एक मोटर डिज़ाइन करना है which will take 220 volts, 5 ampere as an input and will rotate at 1000 rpm. So after designing, if you say that सर ना इसमें ना वाइब्रेशन ज़्यादा आ रहा है, तो दूसरा ऑप्शन क्या है? 1000 की जगह 500 आरपीएम पे चला दूं, वाइब्रेशन कम हो जाएंगे. तो सामने वाला ऐसे ही मना कर देगा, जरूरत ही नहीं है भैया तो डिज़ाइन करने की. मुझे so you are left, obviously you are left with no choice. You have to actually manipulate the design or do whatever is required without changing the input parameters, because if you vary the input parameters you are actually not designing, you are managing. So managing is not done in engineering. So If you cannot, obviously you don't have an option of changing the load, you change the material. If you cannot change the material, strengthen the material. Need to strengthen the material. If if at all nothing is possible, the third option is reject the proposal. That this is not possible. Okay. So you reject the proposal. So how did you actually arrive at this? So you need a strong mechanical technical know-how which will actually describe it. हवा में आप बात नहीं कर सकते. It has to be supported by mathematical or engineering or technical data. Okay, so I'll give you a very small example. The two-wheelers or the four-wheelers that we drive today, they have an efficiency of not more than 40%. So you have a vehicle which is running at 40%. That means you still have a scope of 60%. That 60% is still left to be done because you know that 100% is impossible to be attained. So another 59% you can manage and you have a huge scope for improvement. But practically it is not done possible. ये कहानियों में अच्छा लगता है. So by Carnot theorem or Carnot cycle, we can actually predict that this will, let us say the Carnot efficiency, I'll tell you later on that, let us say that the Carnot efficiency is 60%. Sorry, if you, let us say it is 65%. If the Carnot efficiency is 65%, that automatically clarifies that you cannot go beyond 65%. So these are all statements, these are all mathematical or scientific data based upon which you arrive at conclusions. So these concluding remarks have to be made by an engineer. It is not that you can do it or just simply say that मुझसे नहीं हो रहा है तो इस वजह से नहीं होगा ना. So these all things are very important and you have to have a very good strong hold of mechanical engineering or you need to understand mechanically how things are going around you so that you come back and try to arrive or try to answer those questions which have been given to you. So everything, so I just received a message that your next period will not be held, so I'll be continuing a bit. So these all conclusions you can only draw when you have a knowledge about mechanical engineering and how they work. Okay, so starting with the first term, stress. Stress is, what do you know? It is force per unit area. Stress is given by force per unit area, and the unit is Newton per meter square, or you can say Newton per mm square. Now, the same unit is valid for pressure also. So the same unit is valid for pressure also. Now, pressure is also force per unit area, and it has the same units. So there are obviously has to be a difference between stress and pressure. So the definition of stress is it is the internal resistance offered by a body due to applied load. It is the internal resistance offered by a body due to applied load. So now let us try to understand that what is applied load. Suppose you are applying a load P on this member. So what happens that this P has number of molecules within itself. So let us say these are molecules. Now the understanding of this force is it will try to elongate the body. So trying to elongate the body does not mean that you are adding or subtracting molecules from this. What you are trying to do is you are trying to break this intermolecular force of attraction and increase this intermolecular spacing by a certain amount so that the net body is elongated. So this is a force. This has been applied on a body, and the net effect of it is trying to increase the distance between two subsequent molecules. Now these molecules have a strong force of attraction, and they do not want to increase, or they do not allow us these increase in dimensions. So what they do is they provide a resistance to this load. So the internal resistance that these molecules provide to the applied load is called as stress. So this stress is a molecular phenomena. The stress is a molecular phenomena, and pressure is external resistance. The external resistance offered by a body due to an applied load is called as pressure. Now pressure is a surface phenomena. Pressure is a surface phenomena. So you need to understand that stresses they occur on the molecules. Pressure is something which occurs on the surface of the body. So when I say that it is stress, that it means that there must be some molecular interaction going on within the body, which is producing this effect. So this is called as stress, or this is called as pressure, and this is the basic difference between stress and pressure. So this is about pressure, stress, etc. Now the, this stress is being produced by load by area. So this obviously involves a term load. Load means the unit is either Newton or kilonewton. Now how is this? This is kgf multiplied by acceleration due to gravity 9.81. All practical loads, all practical loads are acting downwards. All practical loads are acting downwards because to apply a load against the gravity, you need to put an effort yourself. And to apply a load onto the gravity, you are standing on the ground, your weight is 90 kilo. That means if it is 90 kg, then 90 multiplied by 9.81, this is the net amount of load that you are transferring onto the ground without actually doing anything. But if this 90 into 9.81, if it has to be transferred to the on the other side, then what you need to do? You need to put an extra effort. So load लगाने के लिए भी load लेना पड़ेगा. So this is the situation. So all practical loads are acting downwards. So if all practical loads are acting downwards, you need to make understand like their terminology according to their effect. So if this is a load, if this is a body, and this has been applied by a load. So this is the load, let it be denoted by P. What is the effect? The effect is elongation. The body will try to elongate itself or the length will increase. So the force which tends to elongate the body is called as a tensile force. And the effect or the stresses and the stresses produced out of it are called as tensile stresses. So if a body is acted upon by a load which tends to elongate the body, then it is called as a tensile force and the effect is called as tensile stresses. Similarly, if this is the load being acted on, the effect is compression. So compression means it will be termed as compressive force. And the stresses arising out of it will be called as compressive stresses. Okay. So the net effect here is elongation means the length will increase due to this load, and due to this load the length will decrease. Okay. So you may have situations, there are situations or there are practical examples where the load shown is acted as compressive and the net effect may come out to be tensile. So this is obviously not a part, this is something which is left for higher studies that we see. But right now you can understand that if the net effect turns out to be decrease in the length of the body, it means that it is acted upon by some compressive force and the resultant or the effect is compressive stresses. Similarly, if the effect visible seems that the body is elongated by a certain amount, then it is called as a tensile force and the corresponding stresses are called as tensile stresses. Okay, so this is about the nomenclature of forces and stresses depending upon the effect they are actually producing. Okay, so now next comes strain. Strain is change in length by original length. Now this is a dimensionless quantity. Why it is a dimensionless quantity? Because on both the numerator and the denominator you have the same dimensions. So strain, it is denoted by epsilon. So this is given by L2 minus L1 divided by L1, where L1 is initial length and L2 is final length. Okay. Now stress, this is sigma is used to denote stress. This is given by force upon area. Force is where P is force and this is cross sectional area. Okay. To make you understand a cross sectional area, let us say that you have this body. Let us say this is L, this is B, and this is h. These are three dimensions. Okay. So if I am applying a force here, if I am applying a force here, the cross-sectional area is P into H. If I am applying a force here, the cross-section area is L into B. If I am applying a force here on the top, it is P into A, sorry, H into L. So the definition of cross-sectional area is it is the area of the plane perpendicular to the direction of application of load. It is the area of the plane which is perpendicular to the direction of application of load. So cross-sectional area obviously does not mean that you will be simply multiplying two parameters and getting the cross-sectional area. So you need to understand what do you mean by cross-sectional area. So cross-sectional area, the definition stands that it is the area of the plane which is perpendicular to the direction of application of load. So this is stress, this is strain. Now you have Hooke's law. Hooke's law states that under elastic limits, stress is directly proportional to strain. Okay. So this means stress is directly proportional to strain, or stress is equal to E into this, where E is your proportionality constant. This is also called as Young's modulus, and this is also called as uh, elastic modulus. So these are few names which define E. So this is the relationship for Hooke's law, where stress is equal to E into strain. And this can also be written as delta L by L. Okay. Now, what we have seen is stress is equal to E into strain. So stress was given by P by A. E remains as usual, and strain is given by delta L by L. So delta L can be written as PL by AE. Now this is the most fundamental equation in strength of materials. Most fundamental equation in strength of materials, where delta L is given by PL by AE, where P is applied load, L is length of the body, A is cross sectional area, cross sectional area, and E is Young's modulus, or you can say modulus of elasticity.